All right, everybody, welcome to class today. Hopefully we'll keep this short, sweet, and to the point. You can see I don't have a whole lot of slides to get through here. So today we're going to talk about section 3.5, using properties of parallel lines. So really, if you guys haven't picked up yet, we're dealing a lot with parallel lines this chapter. And really, this is just going to be using what we've been talking about the last couple days. So, in the setup here, really what we had was the long line here, that transversal represents a boat, and then lines M, N, and K are representing the oars of the boat. So in your book it talks about rowing a boat. So they tell you lines M, N, and K represent the three oars from that boat. They tell you that M is parallel to N and N is parallel to K. And we need to prove that M is parallel to K. So we want to show that this line and this line are parallel to each other. So we can see the proof. As always, we start with our given information. Again, we know that M is parallel to N because it is given right here. So right here, again, if you want, you can put both of those in the same step. You know, your book splits them in between 1 and 3 here. I like to just get it out there. If you want to do it this way, though, that is fine. Either way, we know that angle 1 and angle 2 are congruent. Okay? Because angle 1 and angle 2, or because lines M and N are parallel, we know angles 1 right here and angle 2 right here are congruent because they are corresponding angles. Okay? They're on the same side of the transversal, and they are both above those parallel lines. So that is our corresponding angles postulate that we talked about earlier this week. Okay? Next up, they say N is parallel to K. That's our given. Okay? Again, I would probably move this up there and call it good, but for whatever reason, your book didn't want to use that information yet, so they held off on putting that out there. Then they say that angle 2 is congruent to angle 3. Again, okay, they're both on the same side of the transversal, and they are both above those parallel lines because N and K are still parallel. Since they are on the same side and above the lines, they're again corresponding angles. So we use our corresponding angles postulate to say that they are congruent. Finally, we can say that angle 1 is congruent to angle 3. Okay? Since angle 1 and angle 3 are both congruent to angle 2. That's the key here. Since they are both congruent to angle 2, they are going to be congruent to each other. Okay? So that is our transitive property. And finally, from there, you can conclude that M is parallel to K, showing that this line here parallel to this line, which is exactly what we want to do. And that is our corresponding angles converse. So just a little proof of that corresponding angles converse. Little proof there using both good corresponding angles and that converse. Couple more theorems here. Theorems about parallel and perpendicular lines. Just some more tools in the tool chest here. Theorem 311 doesn't have a fancy name, but hopefully this kind of makes sense to you guys. 311 says if two lines are parallel to the same line, then they are parallel to each other. So what that's saying here, in my picture, if line P is parallel to line Q, and line Q is parallel to line R, then P and R have to be equal, or parallel to each other, not equal. Okay, which hopefully that makes sense. If It's a little bit kind of like the transitive property, but instead of being congruence or equals, it's more of a parallel lines. But hopefully, if you have two lines that you know aren't going to intersect, and one of those lines isn't going to intersect with a third line, R, then it would make sense that the first P and R aren't going to intersect with each other. Then, Theorem 312, in a plane, if two lines are perpendicular to the same line, they're parallel to each other. So, if I get these right angles here with line M and N, both perpendicular to P, therefore, they are going to be parallel to each other. We did kind of talk about, the other side of that the other day, where we had one line being perpendicular, and we knew they were parallel. Now we know they're both perpendicular, and we can say that they're parallel. So just kind of flipping that around from the other day. Okay, so in the diagram on the right, each step is parallel to the step immediately below it, and the bottom step is parallel to the floor. We need to explain why the top step is parallel to the floor. So basically, showing what this Theorem 311 says here. So to start out, okay, we are given that K sub 1 is parallel to K sub 2, and okay, so saying first two lines are parallel to each other, K sub 1, K sub 2, and K sub 3 is parallel to K sub 4, the line representing the floor. So these two lines here. Okay, using Theorem 311, which again has no name, but it's the one that says two lines parallel to the same line are going to be parallel to each other. Using Theorem 311, we know that K sub 1 is going to be parallel to K sub 3. Since K sub 1 is parallel to K sub 3, and as we've already stated, K sub 3 is parallel to K sub 4. Then it follows, or basically just a nice fancy way to say, then we know that it follows that K sub 1 is parallel to K sub 4. So the top step is parallel to the floor. So just kind of talking through so that we can use that Theorem 311. We couldn't just jump from K sub 1 being parallel to K sub 4 because they didn't have anything in common. They weren't parallel to the same thing. That's why we had to show that K sub 1 and K sub 3 were parallel to each other so that we could use that K sub 4. All right, guided practice. Obviously, I am not going to sit here and wait for 5 minutes for you guys to work on your guided practice. So what I would do, pause the video, okay? I will take a break here for a second. You work it out, figure out what you need to, and then and then resume the video, and I'll go through these. So go ahead and pause the video now. All right, welcome back. First, all we need to do is state the theorem that we can use to prove that R is parallel to S. So number 2 says R is parallel to T and T is parallel to S. That is the wonderful setup of theorem 311. Saying that two lines that are parallel to the same line, in this case R, or T, I guess everything's parallel to T, therefore R and S have to be parallel to each other. And number 3, I tell you R is perpendicular to T and T is perpendicular to S. That is a great setup for theorem 312 that we talked about today. Again, make sure you're reading what's given to you here. That's the important part here. And determine which lines, if any, need to be parallel. Right away, I look at this, I see M sub 1 has to be parallel to M sub 2 because they are both perpendicular to L1. Perpendicular to L sub 1. And I know that L sub 1 has to be parallel to L sub 2 because they're both perpendicular to M sub 2. So that one's kind of tricky with all these right angles going on inside here. Pay attention to what is parallel or what's perpendicular to the same line. And number 5, okay, I look, okay, the fact that I have two interior angles here, we don't know for sure that they are supplementary, adding up to 180, but what I do know is that this angle right here is congruent to that angle, therefore L sub 1 has to be parallel to L sub 2 by the alternate interior angles converse. Okay, both inside the lines, opposite sides of that transversal, M sub 1, therefore those are going to be alternate interior angles. All right, you guys have your homework, okay, should be in your notes, so we'll check that when I get back. If you guys have questions, feel free to find me, let me know what's going on, and we'll get you squared around. I will see you guys when I get back.